Hello, this is the part 1 of section 2.7, solving absolute value equations and inequalities. Part 1, solving absolute value equations. The absolute value of a number is its distance from 0 on the number line. For example, the absolute value of -3 equals 3, and the absolute value of 3 also equals 3. To solve an absolute value equation, we are looking for all values that make the statement true. Consider the absolute value equation, the absolute value of x equals 5. What values can x take to make the statement true? Well, trying to use a number line, what this is asking for is if we start at 0, we want the numbers which are a distance of 5 from 0. So we can go 5 to the right, and we get 5, or we can go 5 to the left, and we get -5. So now we have x is equal to 5 or -5. Notice that there are two possible solutions. In general, if the absolute value of u equals a, then u equals -a or u equals a. We will use this relationship to solve more complex absolute value equations. Solve the absolute value of 2x minus 9 plus 4 equals 8 following the steps outlined below. Isolate the absolute value term on one side of the equation. So when I say the absolute value, when I say isolate the absolute value, what that means is to get this expression by itself. So the only part of this equation that is not in that expression is the 4, so I'm going to subtract the 4 from both sides. So you get the absolute value of 2x minus 9 is equal to 4. Now that we have the absolute value by itself, step 2 is to rewrite the absolute value equation above as two equivalent equations using the relationship if the absolute value of u equals a, then u equals -a, or u equals a. So for this specific one, that means 2x minus 9 equals -4, or 2x minus 9 is equal to 4. So then we get Step 3, solve the two resulting equations using techniques of solving linear equations. So for 2x minus 9 equal to -4, I'm going to add 9 to both sides, get 2x is equal to 5, divide by 2 on both sides, and we get x is equal to 5 halves. And then 2x minus 9 is equal to +4, add 9 to both sides, we get 2x is equal to 13, divide by 2, and we get x is equal to 13 halves. So we get two equations. Example 3, solve each equation using the process outlined above. So for part A, the absolute value is already by itself, so we're going to split it up into two equations. So we get x plus 3 equals -10, or x plus 3 equals +10. Subtract 3 from both sides, we get x equals -13. Subtract 3 from both sides, we get x is equal to 7. And those are our two answers. Part B also has the absolute values isolated already. So I'm going to split it up into 3x minus 5 equal to -12, or 3x minus 5 is equal to +12. Add 5 to both sides, we get 3x is equal to -7, divide by 3, we get x is equal to -7/3, and repeat the same two steps with the second equation, and we get that x is equal to 17/3, again getting two solutions. Now for part C, the absolute value is not isolated, so the first step will be to subtract 11 from both sides. And we get 2x plus 8, absolute value, is equal to -4. Well, then this is actually a problem. This is saying the distance of 2x plus 8 from 0 is equal to -4. So even though we can get negative answers like we did in part A and part B, It just happens to be when you plug those negative numbers in, they become positive. But an absolute value can never equal a negative number. So there is no solution here because an absolute value of u is never equal to a negative number. Some of our absolute value equations may involve absolute values on both sides of the equation. Consider the absolute value equation. Absolute value of x equals the absolute value of negative 5. What values can x take to make the statement true? Well, we get the same thing because this becomes absolute value of x is equal to 5, which means x equals 5, or x equals negative 5. Notice again that there are two possible solutions. In general, if the absolute value of u equals the absolute value of v, then u equals negative v or u equals positive v. We will use this relationship to solve absolute value equations with absolute value on both sides. Example 5, solve each equation below. So again, we get two absolute values, so this will be 2x minus 4 equal to 5x plus 8, or 2x minus 4 equals negative 5x plus 8. Notice how I'm putting the 5x plus 8 in parentheses when I add the negative sign. That indicates that when we do this equation, we're going to have to distribute. So now we solve. So I'm going to subtract 5x, add 4, add 4. We get negative 3x is equal to 12. Divide by negative 3. Divide by negative 3. X is equal to negative 4. Over here, like I said when we started, we have to distribute the negative sign first. So we get 2x minus 4 equal to negative 5x minus 8. Solve for x. Get 7x equal to negative 4. Divide by 7, divide by 7. We get x equals negative 4/7. And those are our two solutions. And now for part B, it already is two absolute value equations. So I'm going to go x plus 3 equals x plus 11, or x plus 3 equals negative x plus 11. Well, here, when I subtract x from both sides, we get 3 equals 11, which is not true. So we get no solutions from this equation. Doesn't mean there's no solution overall. We still have to solve this one. So then this one becomes x plus 3 equals negative x minus 11. Now when we add x to both sides and subtract 3, we get 2x equals negative 14. Divide by 2, divide by 2, we get x equals negative 7. And now we only got a single solution this time. And that's it for part 1 of section 2.7.